Hello, everyone, and hello, Emmer, who joined right as we're going live. We're now live, so thank you everyone for joining and tuning in to the Hallucinations in Document Question Answering webinar. So it should be a really fun one. We've heard this as a big pain point from a lot of folks as they try to put question answering systems in production. And so, yeah, really excited to be here. We've got 4 awesome presentations. Daniel should hopefully be joining. He was on in the green room earlier, and then he went offline, but we hope to see him back here soon. So what we're going to do is maybe we can do quick introductions from everyone. Then we'll jump into presentations from each group for like 8-ish minutes, and then we'll do question answering at the end. Minor logistical stuff before we get started. This is being recorded, so it will be available at the link after the fact. For questions, if you have questions for the presenters, please put them in the question answering box on the right. So you can see there's a little chat icon, and then below that there's a little box with a question mark. Please put questions in there and then upvote the ones that you want to hear answered as well. And those will be the ones that we'll prioritize. If there's immediate things that pop up, like zooming in or audio gets bad during the presentation, please put those in the chat. Although for video quality, I'd recommend kind of like refreshing the page. We've seen that a few times. Yeah, I think that's all the logistical stuff. So maybe we can jump in quick introductions from everyone and then get into the first presentation. Nick, do you want to start?
Yeah, for sure. So hi, everyone. My name is Nick. I'm the co-founder of Mendable. And yeah, Mendable, I mean, if you haven't seen us in the LangChain docs yet, we basically provide chat-powered search for developer documentation.
Awesome. Mathis, do you want to go next?
Yeah, hi. Nice talking to you today, and thanks for the invitation, definitely. I'm Mathis. I'm head of product at DeepSet, and we have an open source framework called Haystack, basically to build NLP applications, and then commercial product called DeepSet Cloud, which is more focused on enterprises building NLP applications.
Great. And Daniel, do you want to go? Oh, we seem to be having some internet connections with Daniel. So maybe Ofer and Amar from Victara, do you guys want to do a quick intro?
Sure. I see Daniel moving again now. He was disconnected for a second. Hey, Daniel, we were asking you to introduce yourself. Want to try again?
Yeah, guys. Check, sound check. Can you hear me?
All good. Yeah.
Awesome.
Loud and clear.
I think all that fixed. Yeah, I'm in WeWork. They're having some troubles. Hey guys, I'm Daniel. I'm a founding engineer at Shepherd. We're an insurtech in the commercial construction space. And on the nights and weekends, I've been hacking on this project called Evaluator, which is an evaluation framework for testing QA systems. Really excited to give you all a demo and share some learnings building that.
Okay, I'll go next. So hi folks, I'm Amar Awadallah. I previously was founder and CTO of Cloudera. Hopefully some of you use Hadoop or MapReduce or Spark or some of the great things we have in our distribution. Currently founder and co-founder and CEO for Victara. And our mission at Victara is to allow you to easily have a conversation with your data. So have an API that make it very straightforward to upload whatever data you have, and then make another call to have a conversation with that data. And then today I also have Ofer with me. Ofer, you want to briefly introduce yourself?
Yes. Hi, everyone. Can you hear me?
Yep.
Yeah. So nice to meet everyone. Thanks all for coming. I'm also at Victara working with Amar on developer advocacy, and have been working on LLMs for a while, for about 3 or 4 years. So I like to think of, we're talking about hallucinations today. I think when it was GPT-2, we just called it nonsense, but it was a different thing because it was just incoherent stuff. But anyway, glad to be part of this conversation and looking forward to what's next in the next hour.
All right, so we've got a packed webinar. Awesome guests. Really excited to hear from everyone. Let's start with you, Nick.
Awesome, yeah. So let me share my screen real quick. Screen. All right. Let me know when y'all can see.
I can see it.
Awesome. Great. So let me skip through this. So before we start, I just want to give a quick overview of Mendable again. So we provide chat-powered search for documentation. We're in the LangChain docs, the Lemma index. Right now, we're currently focused on developer-focused companies and enterprises. And we provide like embeddable components, if that's on React, JavaScript, and our API, so you can implement chat in your own products. So going to next year, I think it's pretty important for us to define what we're talking about in hallucination. And I think like everyone has kind of like a different definition of what hallucination means. So I'm gonna go with what Mendable thinks and what Mendable defines as a hallucination in our evaluation data set. But I would love to hear from everyone what a hallucination really means. So for us, it's when the AI model produces a result that was not present or formed on the documents that we fed through the prompt. So that's when we call it a hallucination. And I mean, in our use case, this often leads to incorrect result, but not always, right? Because it definitely leads to creative answers sometimes. And I mean the incorrect results part as because the model probably wasn't trained on our customers' data, for example, right? So the model has no idea what it's seeing. So if we feed something wrong, the model will most likely produce something incorrect. So that's how we define, but I would love to hear from our speakers here what they think hallucination really means.
Well, so one comment I have here, and I'm curious for other takes as well, Jed, but so just to clarify, like there's kind of like getting a question wrong or hallucinating because so you're doing like retrieval augmented generation where you have a question, then you retrieve some documents, and then you basically ask the model to come up with some answer based on those documents. And you're saying hallucination is when like, could you go back to the definition? It's like it produces a result that was not present or formed based on the documents fed through the prompt. So I guess like how do you think about or like do you distinguish between cases when like because the big step in there is the retrieval step, right? And putting the documents into the prompt. And so, yeah, how do you think about that and distinguish between that and hallucination? Like, is there a hallucination where it like retrieves the right results, but the model just doesn't pick them out? And is that like, and how do you think about that differently from when the model doesn't retrieve the right results, or maybe retrieves like half of the results and and hallucinates half of it or something? Like, how do you? Yeah.
Totally.
Can I give an example? Actually, it's a very funny example. A very famous reporter from the New York Times. I'm not going to say his name, but his name starts with C, and he was at some other famous machine learning company. Their name also starts with C, which is very interesting. And they had indexed their documentations, and then they asked a question: "What is temperature?" And temperature about large language models here, right? Which is the randomness in the output words being produced. And the response came back explaining temperature well, like in terms of the context of a large language model. But then the last sentence was, and temperature is measured in Kelvin. Now, that was hallucination because this is not the same temperature that we use for physics. This is the temperature that we use for large language models. So that's what we mean when we mean hallucination. Like there's additional output that the model contributes that has nothing to do with the facts that we give to it.
Exactly. Yeah, I think this is it's really interesting. I think exactly. The information retrieval piece for us is very critical. But there are cases where, of course, there's like not the majority of cases at all, but there are cases where the we did pass the right documents and it actually didn't like complete. And those are honestly like the hard ones to really like auto evaluate. Normally we need to like one of the biggest things that we do is we go manually through it and see it and check it. But moving forward here, I think like some ways that we use to reduce general hallucinations, I think this is really important. And the first one is like pretty classic and pretty obvious, and it would be like a true prompt engineering. So I think here like some 4 techniques I listed here that we use and that might help you in your use case. So like the first one is like a request for evidence, right? So like always making sure like, hey, according to the provided documents, refer to the documents when answering, quote the original document. The second one is like setting boundaries. So this is what we basically set a boundary in the prompt, like, hey, here's where the verified documents are going to be. Here's where it's going to end. Answer solely based on that chunk. And then another one is the step-by-step reasoning. You've probably seen in a million websites, but let's think step-by-step. How can we answer this based on the provided documents? And I think my favorite is the describe first in detail, and it's probably very similar to what ChatGPT does, but basically like describe the question in detail before attempting to answer. Really provide that description. Really like teaching them, having the model say exactly what it's thinking, so it can basically be more creative when completing. I think it's really important.
Nick, can I ask one quick question on the
Yep.
request for evidence bit?
Mm-hmm.
Do you verify that the documents that they quote or cite are actually valid documents that were kind of like passed in based on the retrieval step?
Yes, we do. We do verify if the documents is actually correct. We do have we also like, that I'm going to get into later, but we do something that helps us a lot is like evaluating each step of our pipeline separately. So we have like an evaluation system just for the retrieval mechanism. We have an evaluation system just for the completion mechanism, but we also have an evaluation system that takes into account like both the retrieval and the completion, and we need to make we try to make sure that those documents match the right ones. Yeah. So I mean, going on the retrieval system, I think another general way to like reduce hallucinations is just improving your retrieval system, at least for us, right? Because we are doing all this document injection in the prompt. So for us, having a good retrieval system means that our answers are going to be really good, or are going to be better than. So basically, like, for those of you that are not aware, like if you're like retriever, for example, for us, if it grabs irrelevant documents that are not split accordingly, the completion will probably hallucinate most of the time, at least in our use case. So investing in a good IR evaluation system is really important. Also, like how the way you split your text, like do you want to have a larger text splitting to maintain context, or do you want to have smaller ones for like efficiency and more accurate cases? And another thing we use, and you guys can hear about on the previous webinars, we use hybrid search, which is a mixture between like the semantic search and keyword search to retrieve the documents, which for us, it does improve quite a bit the results. And you guys can feel free to listen on YouTube. I think on the other webinar, we talk a lot more about that. But just moving forward here, I think.
Nick, I have a quick question for you.
Yeah, go for it.
Yeah, Nick, I'm curious. Would you still consider this a hallucination if the in improper context, improper documents were provided the prompt? Kind of an open-ended question. Anyone feel free to jump in.
That's a good question.
Maybe. So how we think about it is that sometimes we also pass the metadata of the document, and then we look at, okay, from that document enter metadata, could the language model have known that this is not the correct document? So if, I don't know, I'm asking about the revenue of Google, but we pass in a document about Microsoft, and it actually has company Microsoft in the header, kind of, then the large language model can actually know that's not the right document. And what we then do is provide an escape hatch so that it says, if the answer is not there, answer, I don't know.
Yeah.
Yeah, but clearly the relevance is super important for this, right? If you get the wrong documents, you give something bad for the summarizer to work with, and so it'll fail and do a lot more hallucinations, right?
Right. Yeah, I think we would consider us like, I think it would be like a hallucination as like the complete like workflow, but we would identify that was because the IR retrieved the wrong documents and not necessarily the model being wrong and not responding. But yeah, that's really interesting. And so some ways that we use to prevent incorrect results now. So going from the hallucination to like actually being factually incorrect. So, I mean, on the IR retrieval system, we detect when the information returns 0 documents, for example, right? It couldn't retrieve any documents, or the documents are like too low score. So that raises like a big flag for us in the back end. And we're like, okay, like we're not feeding anything to the model. It's just going to be creative. It's going to do what it does. So what we do is we decrease the confidence level to the user, and we let the user know like, hey, like, sorry, we couldn't find the information and documentation provided, so expect your answer to be less accurate. So like, hey, like you may not know what it's talking about. And that's something that we leave a lot to our customers to decide what they want to do. So some of the customers that we work on, like enterprises, they really don't want the model to be like anything creative. It's not confidence if our R fails. So then we just say like, oh, I don't know, like, documents are not provided. And then some of them want the model to be a little bit more creative, because maybe the training data does include their documentation, because they're a big company or something. So like we kind of let our customers decide what they want to do that. And then when they are creative, the model can tries to answer. So it will say like, oh, I'm sorry, couldn't find anything exactly on our documents, but here's an example of how. And then another example.
Nick, I'm very curious. In this setting, do you dynamically set the temperature? Like if you have no documents returned from the retrieval tab, would you update the temperature to be more creative, or would you still have it, I assume, like near 0 if you have at least like 3 documents retrieved?
Right. So right now, I mean, we actually we're testing with actually dynamically changing, but right now we kind of leave up to the customer. I mean, we still let it 0 most cases. But I think that's an interesting take, because then you could potentially, of course, with a higher temperature, get better results. But because it's a customer setting, we haven't done this yet, but we're definitely starting to try it out. It's a great question. So another thing that we do too, it's the teach the model functionality. So we let users revise incorrect results in our end. So we basically we provide some insights to the user based on like how users rate the questions, and also we show all the conversations. And if our customer sees an incorrect answer, they can go and revise it. And then the revision is pretty basic right now. Basically, like they input the correct response, they input the source link. We just reindex into the vector database with some metadata and some higher priority, so that if someone asks us similar questions, it will query that document as well.
And you say higher priority because basically your retrieval step not only takes into account relevance, but also some notion of priority. And so
yes, exactly. So we have we set up in our system to account for like higher priority like sources versus like low priority. So there's a lot of people that want to ingest like their documentation, but they also want to ingest YouTube videos. They also want to ingest Zendesk Help Support Center. And some of those data sources might not be as relevant as the docs, for example, or is not as updated as the docs. So we want to be able to set that priority, so the model knows like, oh, this is the most up-to-date data source. I should probably rely on that one.
Makes sense. Also, we're running a little bit short on time, so maybe let's speed through the rest of the slides.
Awesome. I mean, yeah, I think it's pretty close to the end, and here is just some general evaluation things, and I would love to hear from all you how you all evaluate, but just this is mostly for the audience. I think something that helped us a lot is just having an evaluation system for every step of the process. So having an IR evaluation, having a completion evaluation, having a pre-processing one, and then having one altogether. Second one, of course, is just invest time in creating a great evaluation data set. Your results are going to be as good as your evaluations. So make sure that you went and do the work, even if that takes like manual work for like days. Having a good evaluation data set makes a big difference. The third one is just using OpenAI evals. It's great, and also the LangChain Auto Evaluator. Use the tools around you to help improve the model and improve your responses and reduce hallucination. And I just put something here for the adversarial testing, you know, like having your data sets, questions that will basically prompt the model to hallucinate, or basically that you know that there are no documents, or they're like partial documents about that answer, but you want it to try to either say I don't know, or you want to try to let it be more creative. So I think these are just some general things, general takeaways that we use, and I think it's useful for everyone. Cool, and
Awesome.
that's it, also.
All right. We'll surely get into a lot more around evaluation later with Daniel, but for now, let's transition over to Victara. So you guys are up.
Oh, okay. Let me share my screen. So first, I want to also agree with the importance of evaluation and how that's very critical to do this correctly. I want to highlight a key paper that my co-founder and our CTO at Victara had published and worked on and led the research for a while at Google. Actually, it's not this one, it's this one, the ReQA framework, which is one of the key methods for evaluation, for evaluating retrieval models for Q&A systems. So I don't know if you folks are using it or not already, but you should definitely take a look at that. So with that said, let me jump into my presentation. I'll try to make it very quick here. So this is what the Victara system looks like. Our goal is to simplify all of these steps. These are the same steps, I think, in all of our systems. We all have a very similar approach. You extract the input data from different sources. You encode that data into an embedding space that unifies the information based on meaning, though sometimes you can augment that with keywords to support the hybrid approach. And then you have a vector database that does the retrieval to find the best meanings that match the query that the user is inputting. You use a cross-attentional re-ranker model to re-rank the outputs. That's not necessary, but sometimes that can improve the results significantly. We do actually have a cross-attentional re-ranker in our pipeline. And then finally, calibrate the results and feed them into a summarizer model to provide the final answer that the user sees. So that's what the pipeline looks like. At Victara, our goal is to simplify this entire process. So for our users, they only see this kind of view where they have one API to upload the data, and then another API to issue the prompts and get the answers back from that data. What we focus on is the aspects of making this easier for developers, meaning how do you balance the performance for on-disk versus in-memory, to balance the cost and to balance the retrieval times and the latency of the responses, and keep that at a minimum. How to reduce the hallucination effect, that is the key topic of this discussion today, and then how to do it in a way that is very real-time, meaning the updates can be coming in real time, the documents could be inserted, deleted, changed, etc., and then the effects of that represent themselves in the output right away. One of the key benefits of our system, which my colleagues here might also have in their systems, is that we are cross-lingual, meaning that the input documents can be in many languages: French, English, Arabic, German, Chinese, Korean. The questions, the prompts can be in any language, and the best answer is extracted and provided back to the prompt in the language of the prompt that the user is asking it, the question in. So this kind of removes language as a barrier for finding information. This is some longer term stuff that we want to be working on, which is to add images, audio, and video, not just extract the text out of them, but to add an embedding recognition for what's in them. For example, if this is an image of a Kubernetes cluster, but the word of Kubernetes is not there anywhere in the image, with a proper embedding, you can still retain that meaning. That's not a feature that we have yet, but we plan to add that. I'm curious if some of the other folks, their systems support it or not. We can hear about later on in the conversation. There's a longer-term vision here for all of us, I think, is to move from legacy. Legacy is about search results, right, or search engines, where you have a query string, and then you get back a list of results. I call that legacy. Modern, meaning current, present time, is about answer engines instead, where you issue a question or a prompt and you get back the answer for your question right away. You don't have to click on the results to try and read and find out what the answer is. The answer is provided to you. And if we do that correctly, in some cases, we'll be able to move to what's called action engines, where the answer to that problem I'm trying to solve, for example, my Snowflake system is too slow, the query is not running at the speed it needs to be, and then it tells you the answer, and then it tells you at the end, would you like me to do that for you? And that's what I refer to as action engine. And that's, I think, the longer term mission that many of us are on. We truly believe that in 5 years, every single application, whether that be SaaS, mobile, e-commerce, you name it, will be powered by something like this. I think all of us in this room, not just Victara, we all believe that's the mission that we're after, is to enable applications to evolve from the legacy way for how we interacted with them to a more futuristic way where verbally we can just express what we want and what we need, and it just happens. That's what we're working towards. These are some of the use cases that we can predict and see today. I think that's what many of us are working on here, how to make customer support better, knowledge discovery, and you can see some of the other ones listed here. But I think these are only the use cases that our feeble minds can predict for what is happening right now. I think there will be new use cases unlocked in the future that we can't even predict yet, in the same way that when the iPhone came out, nobody could have predicted Snapchat, but Snapchat still happened, right? And I think there will be some things like that that will happen over time. Now, this was already covered earlier, but briefly, there is 2 ways to have large language models speak about your data and provide answers to your data. The first one is to fine-tune the model, to take your customer data, feed that customer data into a fine-tuning engine to fine-tune the large language model on your own data, and then get a new model that's now trained with your own data, and then you issue the question to that model and you get back an answer. This is actually not ideal to be doing. It has many disadvantages. One of the key ones is it will lead to significant hallucinations, where sometimes you can get outputs that have nothing to do with your data that were in the existing model itself, depending on the temperature and how you set the temperature, obviously. Another disadvantage is training these models can take a very long time. So that means new data coming in might not materialize in the output until hours, if not days later, until the fine-tuning process is finished. And then last but not least, it's very costly actually to do this kind of retraining over and over again compared to some of the other techniques that we are discussing today. So the technique that many of us employ in this conversation today is what we refer to as grounded generation, or sometimes you'll hear the term retrieval augmented generation. I prefer the term grounded generation because I'm a gamer, as you can see from my t-shirt, and grounded generation is GG. So what's a better acronym to go with than that? And grounded generation, in a nutshell, is about we're going to still provide a generative output, but we're going to ground it in the facts. So we're going to retrieve the facts first. We're going to use a high-end information retrieval semantic model that's still using neural networks to find the best facts for that prompt, and then we're going to summarize these facts with the large language model. So that's kind of, in a nutshell, what grounded generation is about. So I have a couple of pictures I want to show you here. This one is just doing the aspect of training a model to be very good at finding facts, meaning the information retrieval model. So you have training data, that's not the customer data, that's training data that trains this retrieval model on how can it be very good at finding the facts relevant to the prompt or the question that the user has. And then once that model finishes training, in training time, we now use the customer data to index it using or encode it. You can hear the term encoding or indexing or embeddings or vectors. This means the process of running that customer data through the model to produce these embeddings that we then store in a vector database. The customer question comes in to the vector database, and then we produce a list of results. That is step number 1. Step number 2 looks like this. This next slide here, and I'm sorry for the animations. Let me just forward through them so you get the final picture. So essentially, this is what happens here, is the question or the prompt from the user goes to the information retrieval model. The customer data have already been encoded with that model into the vector database. The vector database finds the closest proximity vectors using dot product or cosine product or other techniques. You get back a list of results. These are the facts that addressing your question. The same question goes to the generative model, and we tell it, these are the facts for this question. Give us the best response that summarizes these facts into an answer for the end user. And try to not go beyond the facts. And that's the hard part, is restricting the model to not go beyond the facts. And that's kind of a key theme that we're all discussing today. So that's very roughly it. My last slide I want to show you is I asked ChatGPT about some ways to reduce hallucinations. And it gave this very, very long list of ways to reduce hallucinations. The key technique that we're all employing here, I mean, we have some of these other aspects in here, but the key one we have is this number 5 technique, right? Is that we are grounding it in the external knowledge about the question and the underlying data set, and trying to limit the response back to that. But some of these other techniques are also very good, and we're investigating some of them from a research perspective to try and deploy in the product going forward. So I'm sorry if I went over my time, but that's the quick Victara story.
No, that's great. I have one quick question for you before we go to the other folks, which is, so when you're breaking it down in this, like, I mean, we've talked a bunch about kind of like retrieval versus generation as well. And so when you guys are thinking about it at Victara, like, where do you focus? Like, how do you think about those different steps? Where do you focus most of your time? What do you think is the harder problem? Where do you see most of the errors coming from?
Excellent question. Excellent question. So everybody in the industry right now is open source, and lots of the activity happening, of course, from major companies like Stability Labs with Stable LM. Of course, the more proprietary technologies from OpenAI, et cetera. They're all focused on this problem, right? How do we make a very, very good generative model? So that's not what we're focusing our efforts. And I think everybody in this room might be following that approach. We're focused on this. If we can get this to be really, really good, if we can get this information retrieval ML model that retrieves the facts, that then we're grounding the generative model in, if you get this to be superior in its performance, and do it in a hybrid way properly, because sometimes when it's semantic long question, the performance might not be as good when it's a keyword lookup or a Boolean kind of expression question. You really want to mix the best of both worlds. If you do this really, really well, then you win. So that's what we're very, very focused on, is how to make this the best it can be. And then on this part, we'll leverage whatever we can get our hands on out there that does this a good job at that. And there's many, it's become a commodity now where there's many good options for that. Hopefully that addresses your question.
Yeah, it does. Super insightful to hear how you think about it. All right. I'm sure I see a lot more questions, but we'll answer those in the QA part. So Daniel, do you want to take over?
Thanks, Harrison. Guys, I will give you a nice and brief intro around the project I've been working on alongside Lance Martin and Goldberg for the past month and a half, 2 months. It's called Evaluator. And we've built a hosted framework. It's an open source project, but it's also hosted on LangChain. Thanks, Harrison, for sponsoring it. And we enable developers to go from a demo or prototype into a more production environment with confidence. Because one thing I have noticed is that we all have awesome cute demos on Twitter around our QA, ChatGPT for documents. But I've seen a lack of tools. How can we get into a production environment with data behind it? How can we come up to our leaders within our organizations and give them data that our QA chatbot is going to be accurate around maybe 85% of the time? And if that's good enough, we are good to release production. Because in a production use case, think legal, insurance, healthcare. We don't want hallucinations. We don't want false positives. We don't want to damage the brand. And that is something that we care a lot about at Shepherd, which is an insurtech and a commercial construction space. And you can obviously assume, as an insurance company, we cannot afford to tell our users that, we do nuclear insurance in our chatbot. So we have to build guardrails and use data to enable us to go to production. I will give a quick demo of the tool. It is open source. Contributions are welcomed. And I'll let you guys jump in and walk you through. Okay. Are you able, guys, to see my tab, the Evaluator?
Yes, you see it now.
Awesome. So I will walk you through a demo environment over here. So high level, what this tool does is it has 3 stages. Stage 1 is you will provide a document or a set of documents that you want to build your Q&A system with. Let's say here we have added a Karpati podcast from Lex Friedman. And stage 1 is we're going to automatically generate a synthetic test dataset for you. So here we can see the test dataset that was generated by the tool in stage 1. And we use an LLM to do that. So let's say we will put this document in an index, right? We'll randomly pick the index. We'll randomly pick a vector, and then we'll try to come up with a question and answer pair out of that vector. So here we have dynamically generated the test dataset from this document. And the goal here is to enable a developer to automatically generate their test dataset instead of hiring a team or doing it themselves. And we have seen this to be quite accurate and quite effective. It's not perfect. It's not as amazing as, you know, a manual testing, a manual human labor around this task, but it's free. It's automatic. It takes 10 seconds to do. So that's stage one. So stage two is, given the parameters that you will provide here in the left-hand side, let's say a model, you can use maybe Anthropic or GPT 3.5, and chunk size, chunk overlap, all these different parameters that we were all used to when building a QA chain using a LangChain library. We will build in stage two a QA chain, a question answer system for you on the fly. And then step three, we are going to grade that stage two will grade the QA chain against the task data set that we have generated for you in stage one. And then we'll run the experiment. So let's take a look at what happened here. So here we have graded, this is the output of stage three. So we have graded each entry here. And again, we use an LLM to do that. So kind of cool, right? We use AI to grade AI. So we use some clever-ish prompt engineering to do that. So we provide, in the prompt, we provide the question and answer here, and then we provide the observed answer. And then we ask an LLM to provide us with the relevancy and how accurate is that in its own terms. And then all the way at the end here, you can see that we will give you a summary of experiments. So for this demo run, we have 3 experiments that has different retrieval methods and different chunk sizes, different overlap parameters as well. And here we can see how those experiments have scored against each other. So on the x-axis, we have the kind of correctness score, like how accurate those runs have been. And then on the y-axis, we have the latency. I mean, those are really 2 big things we care about right now, latency and correctness. So here we can see that experiment 1, this one, had the highest latency, but also had pretty good accuracy, right? But we also see that experiment 3 had the lowest latency and also had high accuracy. So here we can deduce that based off data and experimentation, we can say that for that set of documents that you have provided us in this tool, these auto parameters, the chunk size 500, overlap of 0, this loops method, and this retriever, are the best ones to use for that chain. And of course, you can keep going and maybe take a look at Anthropic models. So Lance Martin, he released the Anthropic model, Anthropic 100K in Evaluator a day ago, and he did awesome testing around that. We can see that the accuracy is around the same. However, the latency is quite higher there. I will end around here. Just to give you one little thing here. So a playground environment here, you can upload your own text. And if you follow the GitHub link, you will see that. I don't know if you guys can see the GitHub link, but yeah, if you can just click on the GitHub icon here, you will see the repository. You can also find the repository by going to LangChain AI organization. Thank you guys. Let me know if you guys have any questions around that.
Awesome. Thank you, Dino. I put the 2 links for those in the chat as well. And reminder that
Awesome.
After the final presentation by Mathis, we'll be doing question and answers for the whole group. I see a few that are really high upvoted, but reminder to everyone to go over and upload their favorites or add new ones if you have some new ones. So with that being said, over to the last and saving the best for last, I'm sure. So Mathis, you're up.
Thanks, Harrison. Can you see my screen?
Yes.
All right, great. And really neat tool, Daniel. That looked great from a tech background and also sleek UI. I love that. All right. So I want to talk about some strategies that we've been working on detecting hallucinations using smaller fine-tuned models. So the setup is the same. It's about hallucination and retrieval augmentation or document question answering. And we've been trying out a few things. Generally, here at DeepSet, I said it before, we work on an open source framework and a commercial product. you can check that out. And what I'm going to do now is I'm going to skip the basics because we already heard them. And then I'm going to talk about 2 hallucination patterns that we see. I will talk about verifiability and attribution in recent research. There's a few interesting papers that we've been looking at. And then I'm going to share some of the results that we had training smaller transformer models, but also evaluating statistical methods of evaluation, and also some other kind of fact-checking models that we tried. So yeah, this I'm going to skip, and I'm going to go right to the patterns and hallucination patterns in retrieval augmentation with large language models. The first one, we call it not paying attention, pun intended. So this one here, you have a question on the left side, what types of aircrafts operate between Guernsey and Southampton, two cities in England. And then you have a GPT-4 generated answer below that, and then you have some retrieved documents. And if you look at that, at first sight, it kind of looks all right. So there's 2 types of aircraft, and these are Flybe's Embraer jet aircraft and an ATR-72. But if you take a closer look, then you can see that actually in the retrieved documents, the Flybe jet operates between Guernsey and London Gatwick, which is not Southampton. So the model just didn't pick up on that. And we see that pretty often, even with a strong model like GPT-4, that it doesn't pick up on small contextual things in the data. It doesn't make up something completely, but it's pretty frequent. And then the other thing, I think many of you know that numbers. So here I'm asking, or the question from a data set actually is, how long is Krishna River? And here we have a generated answer from u.com, so the generative search engine. And it says that the river is 1,288 kilometers long. And actually, if you look at the supporting document that was cited as a source even, you can see, okay, that's incorrect. And we've seen that pretty often, like that it just cites the wrong numbers for whatever reason. I think in general, they've seen way less numbers than text. So pretty understandable, but can be tricky. And then we thought about, okay, how can we now detect these hallucinations reliably? Because our customers kind of want that the models rely on their data and that they don't make things up. So we looked at a little bit of research. One paper I want to share here comes from researchers at Stanford evaluating verifiability in generative search engines. Pretty interesting. They looked at 4 search engines, Bing Chat, Perplexity, U, and Neeva, and they checked if a statement is supported, and then if that cited reference actually with a citation, and then if that cited reference actually supports the statement. And they found that only like half of the statements had a citation, and then out of those, only about 75% actually supported the reference, actually supported the statement. So you get an error rate of about 25% for the statements that are supported, which isn't great in some contexts. Might be enough for others, but some contexts isn't great. And then this, yeah, the question? No. All right. So, and then the other one, automatic evaluation of attribution by LLMs, comes from researchers at Ohio State, and they've basically developed an attribution score where they judged cited references as attributable, kind of extrapolatory, so that it extrapolates, so it says something that is not in the source document, and then contradictory, so that it even contradicts the document. And then they fine-tuned a range of models on the task. They had some data sets that they repurposed and had a small evaluation set and they found FLAN T5 to outperform both a fine-tuned alpaca and also a few-shot ChatGPT. So even that was surprising a little bit, because even the much bigger alpaca model, which was fine-tuned on the data, underperformed here. And of course, ChatGPT not being fine-tuned on a task, that kind of seems reasonable. And then we've been going down the same route. So we looked, okay, what existing methods are there to evaluate this maybe, and can we train a model? And we took that data set from the first research paper and created sort of like an evaluation set and a training set from that. And the mode that we, the task for the model was basically they get a statement, the Pittsburgh Steelers, when did they win their first championship? And then they get the evidence, which comes from the source document, and then you feed it to the model as statement, separator token, evidence, and then it produces a score. And as you can see here, score is 0.74. That's quite good. We want to work a little bit on that, but it indicates that this is not a hallucination. And we also tested this, of course, on our test set. And what we found is that statistical methods that come from a more translation evaluation background, like Bleu or Rouge, they underperform here a little bit. So they have a low correlation with actual scores, basically. And we also looked at BERT score, which is more like semantic similarity, also not that great. We compared UniEval Fact, a T5 large model trained, I think, last year by a research group. Also not great. And then the debirder model, so very small, the debirder base model that we fine-tuned, has quite good correlation, but we also looked at the results manually, and there's a few things to fine-tune definitely still. And then remaining challenges is that the data set itself, the search verifiability data set, has quality issues. So we found using our model that oftentimes when the model was pretty sure that this is a hallucination, it actually was a hallucination and the annotator made a mistake. So we kind of want to relabel a little bit there. And then we still want to get better performance. We want to kind of tweak the scores to reflect a bit better how a human would maybe perceive that hallucination. And then the question is, as always, how well will this approach generalize across data sets and domains? And maybe also how would we deal with very large context sizes? And that's it.
Awesome. Thank you for the presentation, and we've got 10 minutes for some awesome questions. And continuing off of the last points you were making, Mathis, about valuation, the number one kind of like question is basically, can you provide examples of good IR evaluation models and practices? And so I guess as kind of like talked about, there's two components here. There's the information retrieval step, and then there's also like the generation step. And so I think with the Mathis, if I'm understanding correctly, you're kind of like after the stuff's been generated, like, is it hallucinating or not based on that? And I think that's also what we've talked a little bit most about before in the general context. So maybe like switching to the other side for the IR step in particular. Like, we've heard retrieval is really important. You guys are spending a lot of time there, Victor. You're doing some hybrid search stuff, Nick. Like, how do you evaluate the IR step by itself? Do one of you guys maybe want to take that?
I think.
Yeah, so go ahead.
I think for us, basically, we also evaluated separately. And for that generative task, we look more at metrics like mean reciprocal rank or mean average precision, because you don't want to have recall, because you're probably only going to feed like 3, 4, 5 documents maybe into GPT. So you really want to have that precision at the top, and you don't care that much about the rest of the results. So this is what we do usually.
Yeah, I was just going to say that we focus a lot, as Amr mentioned earlier, about the IR component. That's really kind of core to what we do. And Amin, one of the co-founders, has spent a lot of his career on that. And so there's standard metrics to just optimize the hell out of this engine to make it the best it can be. So we use a lot of the standard metrics you see in sort of academics to optimize this engine in general, not just particularly for a particular, if we use 3 facts or 5 facts or whatever, just to make it the best it could be.
Nick, Daniel, anything to add there?
Yeah, I think for some people, I know some people were asking like, how do you structure like the data set, etc. Like something that we do for the IR eval part is basically we have like the question, we also have like the correct answer, and then what we do is we have basically like a list of IDs that correspond to the documents in our database. So like that list of IDs is basically like, oh, the answer is contained on these IDs. And we also have like a list of like references. So like if you have like basically inside that document ID, if you have like a quote that would answer the question, you'd list them as a reference and you can have that in your data set. And then that way you can know exactly like, oh, the answer is contained on these documents. It can take as a reference this parts of the text, and then you can like correlate and like evaluate like using F1 and etc.
Yeah, I want to stress F1. I mean, F1 is definitely one of the key metrics that even in a lot of our customer engagements, when we're doing evaluation compared to legacy systems they might have, the F1 score is one of the key metrics that we measure to try and show how much better these new techniques are. And as many of you know, the F1 score blends both the precision and recall of the information retrieval model. And that's really what our customers want to see. They want to see a significant lift in the F1 score compared to whatever they have before.
I think, Harrison, I would just add one point over there is simply like when you want to test either the output of the LLM on hallucinations or the retrieval quality, think deeply about the workflow and the process. Like make sure you are storing either in a vector-DB or maybe in a PostgreSQL, you're storing those intermediate results so that you're later enabled to perform the testing either manual by yourself or maybe exporting it into like Scale AI or Mechanical Turk and then hiring someone else to do it for you. Yeah, but like again, without having data, you can't test it.
That makes sense. And actually, so there's another question a bit further down, which is like, what do these kind of like IR data sets look like? Like, is it as simple as there's a question and one document that has the right answer? What if there's multiple documents that have the same answer? What does the labeling for that look like? What if there's questions that maybe need things from multiple different documents? How do you kind of like judge the IR retrieval step of those? I guess like, what do these actual data sets look like in practice?
Yeah, that's a good question. I think, again, double down my earlier point around recording the data that you're producing. And I would double down here is like record everything. With Pinecone, for example, or any other, vector-DB, you have also metadata and you have other, for example, in Vectara, or Mandible, you guys are using priority, like the ranking after the retrieval step. Like record that too. Like really enable yourself to record all the data points there. Yeah, but high level, yeah, it's the top K results that you are querying against. But again, also record the K. Maybe you are setting the K dynamically. Yeah.
And Harrison, yes, I mean, that's why the data sets, there is a human that helps calibrate labeling the data sets on what's the good answer and what's not a good answer. That's how we calibrate against that, because it's very complex, as you correctly identified. Like sometimes the same answer can exist in multiple documents. What's the best one? And that's where we, for the purpose of doing the measurements and calibration, that is what we rely on. So that's why labeling is still very, very important task for that. But the good news is there's a number of very good data sets out there from Reddit, from Amazon, from the Squad data set, from Stanford. There's a wiki-based data set. There's a bunch of really, really good ones out there that people can use. But if you want to do it for your own data internally at your company, then one of the first exercises we would do with you is to create a labeled data set that a human editor helped define so we can do the calibration against.
Yeah, exactly. I think like if you, and also like I would reinforce that you probably want to create a data set that you know like you are an expert on, so you can really like evaluate and like manually, and you know if the right answer is there, so you can save some time. Because yeah, like there's so many data sets out there, but like it's a bit hard to know like, oh, is this the actual correct answer? You know, especially for like even the completion evals. So yeah, just having something that you know, it's important.
Awesome. There's one question down at the end, which I think is a little bit in the weeds, but I think is kind of interesting. Do you, and this gets around kind of like prioritization and importance for documents. Do you dynamically prioritize do you dynamically prioritize different sources based on the input query? So like and I'm guessing the prioritization is probably like fixed, but I guess like, and expanding this to why I think it's interesting, like I think a lot of times when people think of a query, they think of like semantic search or like hybrid search where you're looking up things, but there's also like other metadata attributes that it could be asking about, right? It could be asking about like from an author. And so I guess like this kind of gets to like parsing the query out into different things, whether it be a dynamically prioritized source, as this is kind of pointing out, or just like some type of metadata filter, more so even than some type of things. How do you guys think about, very open-ended, and I know we have 1 minute left, so this is a bad question to ask, but any quick thoughts on that?
My thought is like, how do humans do it, right? So again, we're trying to rely on the large language model to be smart enough that it's gonna both the large language model and the retrieval model together, and the re-ranking model in the middle, to be smart enough to figure out that even without the additional metadata, like we want it to be that good. Like it looks at the question, it looks at the response, like this is really a good response, just because I understand the domain, I understand the language, and I know it's a good response. That said, you are right. Like if we can help it, if you can nudge it here or there, that would help a lot. So we do have custom attributes that you can add in the metadata aspects that can be further used in the ranking functions and for doing the cross-attentional re-ranking to further boost certain sources, to boost recency, if this is a more recent document than not, to boost maybe the social graph connections, meaning this is the CEO. If they posted this, then maybe it's more accurate than if it's somebody else. So you can add these additional elements to try and improve the scoring. But at the end of the day, nirvana is to have the system figure it out based on the information content, that this is the best response.
Awesome. And since the last question, the very last question, what's the husky's name, Amir?
Thank you for the excellent question. She's a Pomsky, actually, which is a mix between husky and Pomeranian, so that keeps her small in size. And her name is Luna, which means the moon. An embedding vector mapping would tell you that right away. Luna, Luna. Yeah.
All right, we're gonna end it there. Thank you guys for joining and sharing all your wisdom. I definitely learned a lot, and I think a lot of really interesting papers to read and things to look into. And thank you everyone for tuning in and all the excellent questions. Hope you guys enjoyed it.
Well, thank you, Harrison.
Yeah.
Thank you for all you do. You're like amazing in terms of how you're building out this community and doing it in a very collaborative way. Like just bring people together. We're all trying to make the world better with this technology, and we really love what you're doing. So please keep doing that.
We're all trying to figure it out.